topic today is about H1N1 vaccine prediction. My targeted audience is the healthcare committees promote upcoming COVID-19 vaccine, hopefully by studying a similar type of transmissive disease and people's reaction to the vaccine. We can learn insights from the data and better educate the public to achieve a herd community. My question to solve, who are the people taking H1N1 vaccine and what are their reasons to take or not? I collect the data from competition website called Driven Data. It comes from a national phone survey back in 2009, and when H1N1 vaccine first became available, the survey covers more than 26,000 participants. 38 questions were asked about their social and economic background, healthcare choices, behaviors, and opinions about the vaccines. My modeling effort covers a range of models. After I input data, missing values using mice, I build a model pipeline. Based on my research, CatBoost is supposed to handle categorical data variables very well. However, the score is unsatisfying, but luckily most of my other models have similar score above 80%. Now I have the good problem to have, like which model I should choose. So for this question, I went back to my original question when I opened up my presentation. So I want to build a tool. I need to think about my product design. And I want this tool to be very easy to use. So I need a shorter survey. And interpretation is very important in healthcare industry. And lastly, my tool is going to be web-based. So I have to consider about the response time for user experience. So that leaves my best option to be a logistic regression, but I'm not done. I also incorporate other models in search for important features. So here's an aggregated bubble chart showing the overlapping top features from a variety of models. These categories indicate 3 types of information. We know a typical vaccine taker is in the age group from 55 to 64 years old with a high income and a higher education level. And their action of taking vaccine is heavily influenced by healthcare-related choices. A very useful piece of information is whether they have taken a seasonal vaccine or not. Subjective opinions matter. Their attitude towards vaccine and awareness of its benefit and risk plays a tremendous role in their decision making. So in order to have a very wide user base and less question in the tools, I focus on the last 2 groups of categories and cut down my features from 38 to 12. And in the end, I threw my 12 features back to the logistic model and further validate if the score metrics are still satisfying. And it shows I have fairly balanced class, and my rogue score is now 88. That's even higher than before. So it means we improved the model and also made it more efficient. Finally, I create an app for H1N1 vaccine prediction using Streamlit. It allows users to upload their own dataset for large group prediction. The sidebar included 12 questions from the surveys that I designed. The health workers can click and drag the survey questions as they go and review the results simultaneously. I also include a coefficient chart from my logistic model for health workers to review and focus on the needed areas to educate the public. Lastly, I include my model workflow for feedback and questions.